This presentation will discuss the principles of the statistical process control method, which is one of the most common techniques organizations use to control the quality of their products. Firstly introduced by Walter Schuhart, this process involves the application of statistical methods and control charts to assess and control quality by analyzing variations and normal distribution. But before further investigating this method, in order to understand why companies put great focus on quality control, it is important to understand what quality is, how its meaning changed through the past decades, and how the characteristics of quality are divided and measured. As only once quality is defined and measured, it can then be controlled. Quality can be defined as the degree to which a specific product or service conforms to a design specification. But it's not just about that. In meanings, not only involves the level of fitness for purpose or use of a product or service, particularly in this day and age, it also refers to the satisfaction of the wants and needs of customers. The first modern approach to quality management date back to the beginning of the past century, where mass production of goods and assembly lines made it necessary for companies that were trying to reduce costs to implement control tools and techniques to ensure that every part of the products manufactured were within the required specifications, so to be interchangeable. Back then, quality was intended to be the mean for cost reductions and ease of production. Fast forward to our present days, globalization, a dense network of interconnections between countries, and various technological advances have made it possible for many companies to expand their reach and operate worldwide by advertising and selling their products and services to customers thousands of miles away. Thanks to the internet and the exponential growth of e-commerce activities, with just a click, consumers can now meet their needs without many of those geographical barriers that once were determining factors of the amount of competition and competitors a given area would have. Hundreds of thousands of organizations from all around the world now compete against each other every day, thus developing worldwide markets and greatly increasing the choice available to consumers. This almost limitless availability has inevitably had the effect of allowing customers to choose what best fit their needs in a very accurate way, progressively shaping their perceptions and expectation when making a selection, thus complicating the modern concept of quality. Irving, in 1987, provided the 8 dimensions of quality in order to highlight these elements. Performance, which also includes functionality, features, reliability, conformance to standards, durability, serviceability, aesthetics, and the perceived image a product or service will possess. While some of these characteristics are easy to measure, others, like aesthetics of a product, might require an analysis of multiple elements like color match or surface finish in order to be assessed. Companies cannot afford to ignore quality, as it has become one of the main factors directly related with competitive advantage and can affect both revenues and operational and reputational aspects of organizations. And additionally, it is now common knowledge that quality must not just be involved in the production stages, but in fact in all aspects of a company. With the internal customer concept, it is recognized that every part of an organization is both an internal customer and at the same time an internal supplier of another part of the organization. Therefore, like a domino effect, errors in the service provided within an organization will eventually affect the productions or service that reach the external customers. This means that each process has the responsibility of their own internal customer-supplier relationships. Almost all companies have now internalized these concepts and carry operations within standardized quality assured systems like the ISO 9000 that guarantee a certain level of standards for all stakeholders, from suppliers to customers. But managing quality not only refers to those techniques that are aimed at reducing errors. More than often, it means focusing on improving processes in general and the ability to produce and deliver in order to satisfy market needs both in the short and the long term.
Statistical process control, also known as SPC, is just one way that firms can measure, control, and predict the quality of their output with the help of scientific techniques. However, how we define quality and its characteristics has significant consequences for how quality is measured and controlled. So firms use techniques such as SPC in order to make their lives easier. SPC relies on statistical methods such as flowcharts, histograms, Pareto analyses, and the like in order to monitor and improve the quality and efficiency of service operations. These techniques aim to verify the adequacy of machinery and other production equipment and assess the competence and efficiency of the process. The process was heavily used by Japanese companies at first and was completely ignored by Western firms until the late 20th century. The process also uses control charts in order to detect any change at all in a process that may affect whatever output a firm is attempting to perfectly produce. All processes should be monitored in case of deterioration or variation in the quality of the production process. Just because products are made under the same conditions by the same machine or by the same person does not mean that all the output will be identical and will often vary in a range of different aspects. Many causes for variation in the output, and they can be put into two separate categories: special causes and common causes. Special causes consist of intermittent, unusual patterns that are caused by the raw materials used, broken tools or machinery, or a wrong data input. These problems can be solved by someone like a managing operator, providing they have the power and expertise to do so. Whereas common causes tend to be more natural or random forms of variation in the output. Common causes tend to be acceptable in most processes, as the process is thought to then be stable and therefore predictable. Examples of common causes can include lack of clear instructions given by management, poor supervision, or even a poor working environment. They require a seeing to from the higher ups, but the elimination of these problems is virtually impossible. SPC has 3 steps. The first step is about the requirement of operators to examine the state of control of the process. It also sets out to answer these questions. Can we do the job correctly? Are we doing the job correctly? And have we done the job correctly? The second step, also known as the process capability study, shows the size and the randomness of the problems compared to the specified requirements expected in the output. The third and final step is the actual process control, the point where the charts come into play, in particular the control charts as previously mentioned. The operation of these control charts are based off of samples taken during the process. The implementation of statistical process control hasn't always been plain sailing for companies. For some firms, as a sole resource, charts cannot solve problems and aren't always an appropriate resource. It requires more outside work and effort, which can diminish the overall efficiency of the company. The implementation has also not been helped by the lack of commitment by people in managerial positions, and it is a process that has been imposed on suppliers who are unaware and unwilling to cooperate.
Honda has really been utilising the statistical process control strategies to screen their tasks at their assembly plant. By applying SPC, manufacturers will better comprehend the capability of the process. They can anticipate the failure rate within the process and making running adjustments so that they don't have real issues happening. The test measures how fast a door needs to be moving in order to close without slamming it. The purpose of this test is to measure the amount of speed that it takes to close a door based on the customer's perceptions. In this test, a sensor is attached to the rear door and an interrupter is attached to the driver's door. Repetitive readings are taken of the closing door. Once this data is collected, it is put into a computer and a statistical software package is used to analyse the data. SPC control charts are used to analyse this data. During one test, a result extended the upper control limit on the control chart. This indicated that one door on a certain car took an unusual amount of speed to close the door without slamming it. The data suggested there was an assignable cause potentially present. This assignable cause was investigated and it was found to be a problem with the fixture used to install the striker. When the striker is slightly offset, it will cause the door closing speed to be higher than normal. Some positives include it is an impressively straightforward cycle and helps in understanding the failure rates regarding specific processes. These measurements can then be utilised to make future changes. Additionally, specialised software packages are used to investigate test information at Honda. This adds to the quality of their finished results, as this software can process immense measures of factual information in no time at all with precise outcomes. Lastly, to monitor process capability, Honda uses SPC charts and histograms. The benefit is that an ideal exact portrayal of the information that has been gathered by various computers. It helps to distinguish inconsistencies inside the modern cycle. These charts help getting the industrial processes in accordance to the industrial standards by regularly monitoring them. Some cons include the speed of door closing tests depends on information gathered from customers' perception. This is a subjective matter. There are also disadvantages from the SPC diagrams and histograms. Wrong interpretation can prompt additional time to being used to rectify something that was wrongly interpreted.
This study investigated the use of statistical process control as a tool in the manufacturing firm to improve quality and cost effectiveness. With emphasis on early detection and prevention of problems, SPC was shown to have a distinct advantage over other quality methods such as inspection of final products. There was a need to check gauges and machines and determine need for some maintenance or overhaul work to be carried out as faulty machines could not produce expected quality products. There was need for operators to be trained, new documents to be produced, and actions for the future to be agreed on. There was also a need for reviewing the operations and monitoring key equipment for retooling or adjustment to achieve the required levels of plant performance. The way to being competitive lies in the capacity to surpass clients' requirements and expectations, as well as providing, in the way expected by the client, a quality product, minimal price, on schedule, every time. The Statistical Process Control study was carried out at Metpac. It's an organisation mostly engaged with the assembling of metal packing in the form of motor oil cans, chemical cans, paint, food cans, floor lip tins, bottle crowns, and roof seals. Metpac regularly gathers a variety of information from its assembling processes. It is the examination of this information which provides invaluable insight into these processes. Thus, the variations are identified in the targeted processes for rectification and continuous quality improvement across the organisation. In this case study, we will look at how introducing SPC to this firm can help minimize variations by investigating their origin and making machine adjustments. In the study, we'll be looking at the crown manufacturing process more precisely, looking at data before and after SPC is introduced, identifying issues, and comparing the data once the issue has been resolved. These histograms show that after the machine changes were distinguished were carried out, another arrangement of results were acquired, and these results were compared to the initial set of results, the ones on the left, showing that the issue with the bottle crown's height was too high and needed to be reduced. The general machine histograms showed that even though the machine changed word on the circulation of the crown diameter values this time, it also presented a positive skew in the general diameter distribution, yet all quality stayed inside. Obviously, the change kind of disturbed the diameter values with increases in machine mean and in general machine standard deviation.
SPC has proven to be beneficial for manufacturing companies. In the Honda case study, we saw how SPC was used to track down where the issues occurred in the manufacturing process. This proves to be beneficial for Honda. Finding and tackling the issue will help increase the quality of the product. Furthermore, in the second case study, we saw SPC being used to improve cost effectiveness of bottle crowns by applying SPC to determine the ideal height and diameter. After SPC was applied, both targets were achieved for the height and diameter of the bottle crowns. Both studies have shown through data that introducing SPC to the assembly process, both products have improved in quality and cost effectiveness. SPC may be too dependent on employees' abilities of analyzing and recognizing issues within the chart. It relies on management to fully explain the role of SPC. Few employees may feel insecure about the position and be reluctant to report issues. Furthermore, another drawback of SPC is its cost. It's not just the purchasing of the software that's costly, but also the training, as external companies will have to conduct the training for the manufacturer. Lastly, SPC accentuates early location and prevention of problems, which can be an advantage to the production of quality products. However, it requires time to apply thoroughly in a manufacturing setting.